Hello, today we're going to be going over section 2.2, which is titled Conditional Statements. And there are two learning targets for today. The first one is to recognize conditional statements and its parts. And the second one is to write converses, inverses, and contrapositives of conditionals. Now, when you write your learning target and convert it into a question, you can choose either one of these learning targets. You only have to do one. If you want to do both, you certainly can, but I'm only expecting one. Just make sure you are answering the correct question pertaining to your target and not the other one. Okay, so the first definition that I want to go over is a conditional. And a conditional is anything that is an if-then statement. So an example could be, if you get every question right on the quiz, then you will get an A. Or if it is 20 degrees outside, then it is freezing. Or I can't think of another example off the top of my head, but it is an if-then statement. So if something starts with if, then you go into an expression, then you have a then, and then you go into an expression. That is a conditional statement. When I use some symbols in math terminology, you will see a P with an arrow and then a Q. So it could be read as if P, then Q. If P, then Q. Okay, the next one I want to go over is a hypothesis. And a hypothesis is the expression that is immediately following the if in your conditional. So my first example was, if you get every question right. That part right there is the hypothesis, and it is known as the P in these symbols and terminology mathematically. The next one is a conclusion, and it is the expression that is immediately following the then. So in my example of, if you get every question right on the quiz, then you will get an A. That part that is right after the then you will get an A. That is the conclusion. That is what will happen if your hypothesis happens. A few examples. If an animal is a robin, then the animal is a bird. So your hypothesis right here, if your animal is a bird, is your hypothesis. The part that is immediately following your if is considered the hypothesis. The next one is the conclusion, everything that has followed the then. So if an animal is a robin is your hypothesis, then the animal is a bird is your conclusion. This whole thing is a conditional statement, and each of these parts are the hypothesis and conclusion. Next example is, if an angle measures 130, then the angle is obtuse. This is your hypothesis. And this is your conclusion. So everything that is immediately following your if pertains to your hypothesis. Everything that immediately follows your then is your conclusion. That is the difference between each of the parts in your conditional statement. So if we have just a general statement, like dolphins are mammals, and we want to convert it into a conditional statement, we have to include an if and a then. So the very first thing when converting this into a conditional statement is write your if and then write your then. So in order to find your hypothesis, or the statement that is right after your if, you have to look at your expression, the dolphins are mammals. So if, say, a dolphin is an animal, so we could say that if an animal is a dolphin, then that animal is a mammal. Then the animal is a mammal. Usually the very end of these statements are going to be your conclusion, and usually the beginning are going to be your hypothesis. But in some instances it will be a bit different. So converting anything into a conditional statement, you must have an if and you must have a then. Those are two criteria of a conditional statement. Another example is looking at vertical angles share vertex. We got to put our if, then we got to put the then. So if vertical angles share a vertex. So maybe if two angles are vertical, then the two angles or the angles share vertex. Then the angles share a vertex. So in our conditional statement, we have our hypothesis with the if, and we have a conclusion with a then. Those are the two criteria of my conditional statement. Okay, every single conditional statement has a truth value. Now, a truth value determines on whether our conditional statement is either true or false. Those are the only two options for a conditional statement to have. So let's say, for example, we have a conditional statement that if a woman is French, then she is European. Well, since France is in Europe, this conditional statement is true. Because if anyone is French, then they are European. That's the same thing as saying if anyone is from Kansas, then they are from the United States of America, since Kansas is in the United States of America. The next one is if a number is divisible by 3, then it is odd. Well, some numbers that are divisible by 3 are 3, 6, 9, 12, 15. All of these numbers are divisible by 3. We do have a few examples where the numbers are not odd. 6 is an even number, 12 is an even number. So we can conclude that this is false. And a counterexample to this conditional statement could be either 6 or 12. Both of these numbers are odd and they are divisible by 3. So this conditional statement is false. Okay, next definition I want to go over is called a negation. And a negation is the opposite of a statement. So instead of saying if then, we could say if not, then something, something, something. Or it could be as a symbol of a little squiggly in front of my P, and it is read as not P. Now in our learning targets, the second one talked about converses, inverses, and contrapositives. So we have already talked about conditional statements where they are if P, then Q statements. A converse is just flipping the letters, flipping my hypothesis and conclusion to where my conclusion is first and my hypothesis is second. So it reads as if Q, then P. If Q, then P. The next one is a inverse, and that is taking your conditional statement and putting not in front of each your hypothesis and conclusion. So if not P, then not Q is how it reads here in orange that I wrote out. The last one is a contrapositive. You take your inverse and you flip the two. So your conclusion comes first and your hypothesis comes second. And there is a not in front of both of them. So if not Q, then not P. This table is very, very helpful in order to find converses, inverses, and contrapositives. So if we have a conditional statement that is if you are a quarterback, then you play football. This is my hypothesis if you are a quarterback. My conclusion is then you play football. The hypothesis is the if, the conclusion is the then. So the converse, we flip the two. We write the conclusion first and then a hypothesis second. So we would write if you play football, then you are a quarterback. You keep your if-then statements where they are. You will always have if first and then second. But the only thing I'm flipping is my hypothesis. My hypothesis and conclusion are flipped in order to get my converse. So instead of if you are a quarterback, then you play football, it reads if you play football, then you are a quarterback. And the inverse is you take your conditional and you just put not in front of both of them. So it would read if you are not a quarterback, then you do not play football. So again, all you are doing is keeping your conditional the same to get your inverse. You're just putting your not in front of them. Now the contrapositive is you take your inverse and flip the two. It is an if not your conclusion, then not your hypothesis. So it will read, if you do not play football, then you are not a quarterback. Okay? And the truth value of all of these statements is that your conditional is true since if you are a quarterback, then you do play football. You cannot play any other sport if you are a quarterback. If you are labeled a quarterback, then the only sport you play is football. Then the converse is if you play football, then you are a quarterback. This is false. In the sport of football, there are other positions besides a quarterback. You have a running back, wide receiver, lineman, linebacker, kicker, punter. There are other positions besides a quarterback in order to play football. So the converse is false. The inverse, if you are not a quarterback, then you do not play football, is also false. I'm just finding the truth value of all of these statements. You can play football and not be a quarterback. Again, the same as the converse. So both the converse and inverse are false compared to the initial statement. Then the contrapositive is if you do not play football, then you are not a quarterback. This is true. If you play another sport besides football, like soccer or baseball or hockey, then you are not considered a quarterback. The only position a quarterback plays is football. So everything here in blue is all of the truth value of these statements. Okay? Thank you.